Okay, hello everyone, welcome. Can you hear me?
Yes.
Okay, just we're waiting 1 minute, then we'll start. Okay, so we'll start
Hi,
today's
good
session. Yeah.
evening.
Hi. Okay, so we'll start our today's session. So basically today is our second day, and I hope already all of you got the previous recorded video class and also get that all of materials. Okay. So after completing the 3 hours live training, then we talk about the problem solving class for the previous first days for the problem solving class. We discuss about that. Okay, so we'll start. Let me share my screen. Okay, can you see my screen? Is it visible?
Yes, sir.
Okay, thank you. So let's go. Okay, so basically for second days, I try to complete this type of topic, filtering and displaying the satellite images. Okay, so how we can easily filter and displaying the satellite images, mainly Landsat, Sentinel or MODIS. So this type of satellite images, how we can easily filtering and displaying, and how we can easily export this type of satellite images from Google Earth Engine. We also discuss about that, how we can easily create the satellite composite. Okay, how we can easily create the satellite image composite, and how to create the band combination. So different types of band combination, how we can easily create in Google Earth Engine. We'll also discuss about that. And export satellite imagery, Landsat, Sentinel, MODIS, or any tip image, how we can easily export from Google Earth Engine. We'll also discuss about that. And import, filter, reduce, clip, and display the raster data in Google Earth Engine. We also discuss about this topic. And also time series analysis, how we can easily make the time series analysis using Google Earth Engine. We also discuss about that. And how to export the shapefile. So different types of shapefile we can easily export, and also discuss about the annual image compose. So let's go one by one. I'll try to complete all of those. Okay, let me open the slide. So we already know about the Earth Engine public data catalog. So this public data catalog, we can easily access all of remotely sensed data. Okay, all of satellite imagery, like as Landsat, Sentinel, MODIS, different types of train dataset, land cover dataset, different types of atmospheric dataset. We can easily access from the Earth Engine public data catalog, and this data catalog is updating daily. Okay, and here we find out more than 200 public datasets, more than 4,000 new images every day, and more than 5 million images in that data catalog, and more than 5 petabytes of data in this data catalog we can easily access. And this is the link about that, so we can easily visit the link, and then you can easily access all of Earth Engine dataset. We can easily access from, basically this is the link for Earth Engine data catalog link. Or if you want, you can simply visit the code editor. So from the code editor we can also access the Earth Engine public data catalog. So just click on the search place, you can see the browse data catalog. Just click on here. So now it open this link. Okay, so this is the link where we find out all of Earth Engine data catalog. So you can see different types of data, climate and weather data, surface temperature, then different types of climate data, atmospheric data, weather data. Also you can see the imagery, Landsat, Sentinel, or MODIS, high resolution imagery for a specific region, also available for the some high resolution satellite imagery. Geophysical data, mainly terrain, land cover, crop agriculture data, or other geophysical data. So it provides a lot of data, or a lot of remotely sensed data we can easily access. Okay, basically all of freely available data we can easily access from here. So when I click on the Landsat, then I find out all of Landsat collection for Landsat 9, Landsat 8, Landsat 7, Landsat 5, Landsat 4, Landsat 1 to 5. So all of collection for Landsat. Click on the Sentinel, then you can easily find out all of Sentinel image collection, such as Sentinel 1 SAR data, Sentinel 2 multispectral instrument data, then Sentinel 3 ocean color and land color instrument, Sentinel 5P tropospheric monitoring dataset. When you click on the MODIS, then we find out all of MODIS dataset. Okay, all of MODIS product we can easily access from here. So now how I can use this type of dataset and how I can filter. So let us go try to discuss about that, how we can easily filter this type of image collection for Landsat 9, Landsat 8, Landsat 7, Landsat 5, Landsat 4, Landsat 1 to 5. All are the same process when you filtering and displaying, all the same process. Okay, because we always use the same function for Landsat 9, Landsat 8, Landsat 7, Landsat 5, Landsat 4, Landsat 1 to 5. So all are the same function we need to use when you filtering or displaying or exporting, same process. Okay, so let's go try to show you that method first. So when you filter your satellite imagery, this filtering is depend on some factor. Okay, so first factor is your region of interest, basically your ROI, your area of interest. So which area you need this satellite imagery. So this is the first factor for filtering satellite imagery. Suppose I need the satellite imagery for the Dhaka city boundary. Okay, so this is my area of interest. So this is the one factor for filtering. Then another factor, it's called the image properties or image metadata. Suppose I need the image, this image will be not more than 1% cloud cover. So I need, it cannot be more than 1% cloud cover. So this is the another factor for filtering, and it's called the image metadata or image properties. Third factor is that a specific time period. Suppose I need the image in year of 2017, month of January. I need the image in year of 2017, summer season, rainy season or winter season. So when you filtering your satellite imagery, it can be Landsat or Sentinel, both are the same process. So when you filtering the satellite imagery, it depend on three factors. First factor is region of interest, which area you need the imagery. Second factor, it's called the image metadata. Suppose this image will be not more than 1% cloud cover. So this is the another factor, and a specific time period, basically when you need the image. Suppose I need the image in year of 2017, month of January, or in summer season or rainy season or any specific time period. Okay, just be filtering the specific time period, then it will be okay. So just we use this three factor and filtering our images, basically Landsat or Sentinel, both are the same. So let's check the practical example, then you can get the more better idea. Suppose I want to work with Landsat 9, just click on the Landsat 9, Landsat 9, Landsat 8, Landsat 7, Landsat 5, Landsat 4, Landsat 1 to 5, all are the same process for filtering. Okay, so I will show you the one example for Landsat 9. Click on here. So here we find out, you can see this type of Landsat 9 images. First one is for surface reflectance data, another is the top of atmospheric data, another is the raw images. Okay, so raw image without filtering, without atmospheric correction, without enhancement. But when you work with top of atmospheric image collection, it already calibrated top of atmosphere reflectance, and when you work with surface reflectance, it already atmospherically corrected surface reflectance. So when you are using these two, surface reflectance or top of atmospheric, you don't need any kinds of correction, because this already complete the correction. You can see it also show the message about that, atmospherically corrected surface reflectance. Okay, so this thing is already, atmospheric correction is already done. So that's why you are not doing any kinds of atmospheric correction is not need when you use the surface reflectance. Also top of atmosphere, it also done. But when you work with raw image, so then we also need to some correction. Basically raw image same as like USGS website Earth Explorer. This image is the raw image. Okay, so for this raw image, further filtering and atmospheric correction for the surface reflectance as well as also top of atmosphere reflectance. Just remove all of unnecessary pixel and also enhancement. So let's go. I just click on the surface reflectance. So now we find out all of information for the surface reflectance satellite imagery. So you can see it's available for the Landsat 9. It's available from 2021 10/31, and this is the last time period about that. Okay, so 2025 05/14. So this is the last time period. This is the update time, and this is the dataset provider USGS. Okay, it's provided the USGS, and you can see this is the snippet ID. It's called the Earth Engine snippet ID. Every image collection or every data set, we find out this type of snippet ID. Okay, this snippet ID basically it stored the full data set. Okay, this is the one kind of directory. Okay, you can see it's one kind of directory. So e.image collection, image collection is one kind of data type in Earth Engine. We already know about that. So this data type, it is stored in this directory. Okay, this is the one kind of directory or folder directory. So this directory, you can say the Landsat 9 collection to tier 1 level 2 data. Okay, so this is the directory about that, and every data set we find out this type of snippet ID, as well as if you check, we find out this type of band. So it's available. You can see the SRB1, SRB2, SRB3, SRB4, SRB5, SRB6, SRB7, basically B1, B2, B3, basically postal aerosol, then blue, green, red, near infrared, short wave infrared 1, short wave infrared 2. So all of band we also get in here, as well as it also give the scale value and also give the offset value. Okay, it's very important to extract the accurate pixel. Okay, this scale value and offset value further we also need to use, okay, to get the accurate reflectance value, okay, from the satellite imagery. So this all of information you can also get in here, as well as if you click on the description, then you can get all of description about this data set, also image properties. Okay, so now I want to use this satellite imagery, this data set I need to import in my code editor. So this is my code editor. So how I can import this data set? It's very easy. Just copy the snippet ID. This ID, just copy. Just copy. And then paste here. Okay. And then give a variable name. You can put any name as a variable. Suppose I just put the variable name as a, I put the name suppose L9. Okay, you can put any name. So this is my var keyword and this is my L9. It's one kind of variable. So this variable stored this image collection. Okay, and this image collection basically Landsat 9 collection to tier 1 level 2 data. Okay, so this image collection I just store it in this variable L9. It is stored. So now I want to check how many images are available in this collection. Okay, and this image is available for the whole world. Okay, it's available for the whole world. So I want to check how many images are available in this collection. So for that, just use the print function and call the L9, because this variable is stored the full image collection, and I want to compute how much images are available in this collection. So for that, simply use a function. It's called the size function. Okay, size function, it's computing how much images are available. Okay, so if I run the code, now it displays the result. It number computing, you can see it computed the total number of images, how many images are available between this time period 2021 to 2025. For this time period for the whole world, how many images are available, we find out. So this is the total result, we find out. This is the image collection, total image collection, and this total image collection is available for the whole world between this time period 2021 to 2025. So this large number of image collection I need to filter. Okay, so for filtering, how I can filter? So first factor, where you need the image, then how mainly, suppose I need the image less than 1% cloud cover. Okay, and then when so when you filtering your image collection, so in this case I find out the large number of image collection. So this image collection I need to filter. So how I can filter? First factor is where you need the image. So this collection display the result for the whole world, but I don't need for the whole world, I need only for the specific boundary. So it's called the where you need the image. Then how? So it's including all of cloud level, but I need less than 1% cloud cover. And when you need the image. So when basically this image is available between this time period 2021 to 2025, this is the time period we find out the image. But when you need the image, when is your specific time? So just you simply put your specific time, suppose 2021 month of January, or summer season or rainy season. So now we are just use the where, how and when, and filter this large number of image collection. Okay, so let's go, we try to filter one by one. So first of all, I need to put the study area. Okay, suppose I need this satellite image for the Dhaka city boundary. So just here I already imported my boundary shapefile. So just let me import the boundary shapefile. Yeah, just I import. So this is the Dhaka city boundary shapefile. Here I already imported, and previous class I already show you that how we can easily import the shapefile. Okay, so now I give a variable name, suppose ROI. I want to display the layer, so just put here map.add layer and call this ROI, and also focus the study area. Map.center object is ROI, zoom level suppose 10, and run the code. So now we find out this is my study area. It display the shapefile boundary. So I need this satellite image only for this boundary. Okay, I don't need for the whole world. So this collection, it show that it display the result for the whole world, but I don't need for the whole world. I need this image for this boundary. So how I can filter for this boundary? So let's go for the filtering these things. Okay, so another thing is that you can also go to the docs tab. In the docs tab, you just click on the image collection. Okay, image collection. So now we are working with image collection. So image collection is our data type. So just click on the image collection. So now we find out all of function about the image collection. So all of function we can apply in our image collection data type. Okay, so now this is the image collection, and I want to filter for my study area. So for that we need to use a function. This function called the filter bounds function. You can see the filter bounds function. So this is the filter bounds function, shortcut to a filter a collection by intersection with geometry. So now I have a collection. So this is the total number of image collection. This collection I want to filter by intersection with my study area. Basically this is my geometry, or this is my boundary. So for that we are just apply the filter bounds function. So you can see the filter bounds function, and this is the argument about that. Okay, this is the geometry. Geometry basically it's a collection. Okay, it's a feature collection or geometry. So in this time I want to work with the shapefile. Okay, basically feature is one kind of shapefile, or geometry is a boundary area. You can also use the point, line, polygon, also there is no problem. So I want to use the filter bounds function because it shortcut to a filter a collection by intersection with our geometry. Okay, so let's go, we try to use the function and filter. So for that, take a variable I put the variable name, suppose filter region. Okay, so in the filter region, so this large number of image collection is stored in a variable. This variable name is the L9. Okay, so just I call the L9 and apply the filter bounce function. Okay, filter bounce function. And what is the argument? Argument is that geometry. In this time, my geometry is stored in the ROI. ROI basically it's my shape file. It is stored in the shape file. Just copy the ROI and paste here. So now let's check, just print filter region and then check how many images are available for this boundary. Just use the size function and run the code. So now we find out that only 137 images are available in this boundary. Okay, so now our first time we find out that it's for the whole world. Okay,
Excuse me, sir.
Please.
Yeah, sorry to take you back. Can you repeat how you've added the region of interest? I think I missed out.
Okay, so basically it's a shape file. So this shape file I simply imported from the asset tab. So here I already uploaded. Okay, so previous class I show you that how we can easily upload the shape file. Okay, so from just simply upload the shape file on your study area, and then I just simply click on the, here you can see this, the Dhaka city boundary shape file. This shape file I already stored it. Just click on here, it will be imported, you can see. Then further it's show the table is the default variable name. I just put the name as the ROI. Okay, so this is the ROI. ROI is a variable name, we can put any name as the ROI. So now this is my study area, this is my shapefile boundary. So I display using this code map.at layer and so focus the center of this boundary shapefile. Then I find out this boundary, and then this is my large number of image collection. It's available for the whole world, but I don't need for the whole world. I need this image for my specific boundary. Okay, my specific boundary is ROI because this shapefile or this boundary is stored in the ROI. So just I call the ROI, and this L9 it is stored the whole image collection, all image collection. So just apply the filter bounce function and apply with the ROI, and then we check how many images are available in our ROI. So we find out that 137. Okay. Any confusion?
Okay. No.
Okay, so now we find out that for our study area in Dhaka city boundary, we find out the 137. But I want to apply, suppose I need only for those image, which image will be not more than 1% cloud cover. So it's including all of cloud level. Okay, but I choose a specific cloud level, less than 1% cloud cover image I need. So for that, we need to apply the another function. It's called the filter metadata. Okay, so this is a filter metadata function we have to use for filtering image properties. So in this case, I want to filter cloud cover level. So for that, we need to use it, filter metadata function. So let's go try to use it. Just take a variable, suppose filter metadata. You can put any name as a variable. So now from 137 images, I just choose only for those images, which image will be not more than 1% cloud cover. And this 137 images is stored in a variable. This variable name is the filter region. Just I copy and paste here. And then apply the function filter metadata. And if you check, here we find out the three argument. Okay, name, operator and value. So what is the name? Name basically name of property to filter. Okay, property name, image properties name. If you check it in your image properties, you can see there are a lot of image properties is available. So I want to filter cloud cover. Just I copy the cloud cover and paste here, cloud cover. So first factor is done for the name. Name basically it's a property name. Then operator, you can see we can apply the equal, less than, greater than, not equal, not less than. So different types of operator. So I want to apply less than. Just I copy the less than. Less than and save the value. I set value 1. So now this variable is stored only for those images whose image will be not more than 1% cloud cover. So let's check. We try to check it. How many images less than 1% cloud cover? Just copy and use the size function for computing how many images are available less than 1% cloud cover in our study area. We find out the 29. Okay. So this is the 29 images we find out, and this 29 image is the less than 1% cloud cover for my study area. But what is the time duration? What is the time duration for the 29 images? This time duration is that this is the 2021 to 2025. So this is the duration. We find out that 29 images less than 1% cloud cover. But I want to apply the specific time period. Okay, I want to apply it for a specific time period. So when you need the image. So let's go try to filter it. So just take a variable, filter date, and from 29 images I choose only for a specific time. Just copy the filter metadata because this filter metadata variable is stored at 29 images, and from 29 images I want to filter a specific time period. So just put here the, for that we need to apply the filter date function. You can see, so filter date function shortcut to a filter a collection by a date range. So we can simply put the date range and then check how many images are available in this time period. So let's go try to apply the filter date function. Dot filter date, and now put your specific time. Suppose I need the image in year of 2025 January, then suppose 2025 05, suppose 14. Okay, so now let's check how many images are available between this time period. Just print and filter date and apply the size function. Run the code. So we find out the only for the 4 images are available for this time period. Okay, and so now you can see first time we find out the large number of image collection. So we filter for our boundary, then filter for cloud cover less than 1% cloud cover, and finally filter for a specific time period. So this is our final output. We find out, okay, total 4 images for our study area. And what is the property? So this 4 images is available between this time period. This 4 images is less than 1% cloud cover, and this 4 images is available in my study area. Okay, so first time you can see we find out the large number of image collection. So this is the full image collection. It is stored in the L9, this variable name. I check using the size function, just computing the total image collection. We find out this result. Okay, then where I need the image, I need the image for the Dhaka city boundary. So that's why I simply import the Dhaka city boundary shapefile from my asset tab, and I put the variable name is the ROI. You can put any name as a variable. I display the study area, and then from large number of image collection I just choose only for those images which image is available in my study area. Okay, so I find out that 137. So from 137 I just choose only for those images which image is less than 1% cloud covered. So I find out the 29 images. So finally from 29 images I just choose only for those images which image is available between this time period. So I find out that 4 images is available. Okay, so you can see this is the process where, how, and when. For the where we are use a function, this function called the filter bounds function. Okay, for the how, we are just use a function, it's called the filter metadata function. And for the when, we are just use here that filter date function. Okay, so these three function, these three new function, now I try to talk about that: filter bounds, filter metadata, and filter date. And previous class we learned about the map.add_layer function and also map.centerObject function. And size function I also talk about. Size basically it's computing. Suppose you have a collection, any collection, any dataset collection, so you compute it, how many images in your collection or how many item in your collection, then we are just apply the size function. Okay, so this is the function. And you can see here, if you check our docs tab, in the docs tab you can easily find out in all of function: filter bounds function, filter metadata function, filter date function, and size function. You can easily find out this section ee.image collection, because this type of function we can only use for the image collection data types. Okay, so image collection data types you can also only use this type of function. So that's why this type of function is only available in this section. If you check it, you can see we find out the filter date function, filter bounds function. We can also find out that filter metadata function. Also you can see the size function is also available. You can see size function. Okay, so this type of function we can only use for the image collection data type. Basically there are the total 5 types of data, and every types of data we need to use individual function. This function, suppose filter bounds function, you cannot use in the image, because image is another data type. If you check it for image, okay, I'll show you that. For the image, click on here, it's another data type. In the image you cannot find out the filter bounds function. Okay, because filter bounds function cannot work for the image. You cannot find out the filter metadata function in the image, because filter metadata function is not work for the image. You cannot find out the filter date function in the image, because image cannot work for the filter date function. Okay, you can see it, it's the another function. There is no filter bounds function, filter data function, filter date function is not available for the image. Okay, so it's very important, because sometimes some function is for another data type, but we also use it for the another data types, then it show the mistake. So let's go. So we find out the total four. So now this 4 images we find out 4 images. So I want to check all of information about the 4 images. Just print and call the filter date and run the code. So now it provide you all of information. You can see it compute the image collection. So this 4 element, basically 4 images. You can see the type is the image collection. Okay, so because it total 4 images, so it's kind of 4 image collection. And if you check the feature, 4 images, so this is the first image, type is the image. Okay, this is the first image, this is the second image, this is the third image, this is the fourth image. So this is the image, type is the image. Okay, and what is the acquisition time? You can see this is the acquisition time, 16 February 2025. Okay, and if you check all of information, all of band information, and all of properties, you can see all of properties, cloud cover level. Okay, you can see the cloud cover land level, then collection category, tier 1, collection number 2. So all of information, data acquisition time, this is the time, 16 February 2025. So all of information you can also get from here. So this is the image. We find out that this is the image, 1 2 3 4 image we find out. So I want to display this image. Suppose I want to display the first image in my map. So how I can display? For the display this image, if you check, you can simply click on the ee.image function. You can see ee.image args. Okay, so it represent the Earth Engine image. Okay, so just we put the asset id You can see that it can be string art engine asset id. So now these things, basically this argument is the asset id, and we are need to use this function. Just I copy this function and then paste here, and now I copy the id. Okay, so you can see when I click on the image, suppose first image, when I click, it give me id. So this is the id, asset id. Just I copy this id, just I copy this id, and now just paste here, and it's a string, so that's why I use the quotation and put it. So just I copy this id, and now this thing just stored it in a variable. You can put any name as a variable. I put the name, suppose I put the name is that image. Okay, so now I store it. So now this image is stored in this variable, and now I want to display the image as a layer. So we already know about that function, this function called that map dot add layer. Okay, and I want to add the layer for this image. Just I copy and paste here and run the code. So now it display an image. So we find out this type of image tiles. You can see. So we find out this type of tiles, right? It look like that as a black color without band combination. It show the black color. So if you check it, click on here. Suppose I put here the SRB for red, green, and blue. So I put the stressing 98% and then apply. So now I can see we find out this type of natural color band combination. But this image have a problem. What's the problem? This problem, you can see some part is missing. Some part is not fully fill up my study area. You can see this part is not fully fill up. So for that, let me try another ID and then check what happened. So I try to apply suppose another image. Click on here and I want to check suppose this tiles. Just copy this ID. And run the code again. Okay, so now you can see this tiles is fully fill up my study area. Okay, so this tiles is fully fill up my study area. So now I just use a function. It's called the clip function. Okay, clip. So this image I just clip for my boundary. And what is my boundary? My boundary is ROI because my shapefile is stored in the ROI. So just put here ROI and run the code. So now you find out this type of imagery as a black color. It's the default visualization, look like that. So now I want to add the band combination. So for that, just click on here. Suppose red, green, and blue. And you can see it show very long value. Okay, we need to also reproject this scale value. This type of pixel scale value, we need to reproject it. So how I can reproject it? Very easy. They are already provide the scale value and offset value. You can see in the information, in the bands information. This is the scale value and this is the offset value. So just I use it. Just copy the scale value. This scale value simply multiply. Just use here multiply, and then offset value simply add. So this is the offset value, simply add. So now we find out that proper reflectance value for each band. So just run the code. And now check the value. And now apply, suppose, red band, then green band and blue band. Custom stressing. So stressing is one kind of data visualization process. Suppose I put the stressing level 3, then it automatically show the mean and max range of reflectance value, and then apply. So now it show the result. For stressing level 3 result, we find out this type of result. Okay. Sometime we also apply the stressing level 98%, 90%. So it's different on our map. Okay. Suppose which stress level show the more better map, we try to use it. Okay. Suppose I just put the 98% stressing, so now I can see it automatically change the mean and max range. Just I apply. So now this visualization show using this mean and max range for the reflectance value. We find out this type of result. Okay, you can also increasing the gamma value. So then we also find out the more brightness satellite imagery. Just simply increase and apply. So now I can see now this image brightness is also increasing. Okay. So opacity, sometime you can also decrease the opacity. Then you can also it also look more better. So sometimes also use this type of parameter to create the more better map. So now this visualization I need to import in my code editor. Okay. So how I can import this visualization in my code editor? Just click on the import button. You can see when I click on the import, a new line of code added in here. You can see, okay, it added the new line of code. So these things I need to copy and paste after the object name. So this is our object. So if you check the check this function, layer function, in the layer function we find out this type of object. Okay, you can see object, then visualization parameter, then name. So now I simply add the visualization parameter after the object. I just put the visualization parameter, just copy and paste here, and now run the code. Now this visualization is set it with my images. You can see it will be set this visualization. It show the this type of visualization look like that, and you can see it show the layer 2, but I want to add the name. I want to add the name. So let's go try to add the name. So just for the name, just use here, I put, suppose it's a true color. So just run the code. So now it also added the name true color. You can put any name as a layer name. So now you find out this type of true color imagery look like that. Suppose I want to add the another band combination. So how I can add? So for that same process, just one here. Suppose I add near infrared, then red and blue. Stressing level, suppose 98% I keep and apply. So now you find out this type of visualization look like, and these things I want to import in my code editor. This visualization I want to import. So for that, just click on the import button. Okay, it will be imported. You can see in here, and I want to add the layer. I want to add the another layer for this visualization. Just I copy the same line of code. Just I copy and paste here. Just change the variable name. Just copy and paste here, and I put it's a, suppose it's a false color band combination. False color. Just click to the run. So now it creates the another layer. You can see true color or false color. We can easily find out the two layer in our map. So this is the false color, this is the true color. We find out. Suppose I want to add the more another band combination. So for how I can do, just click on here, and then I want to add the band combination for short wave infrared 1, then near infrared and blue. Just stress 98% and apply. So now it creates another band combination, look like that. And I want to import this visualization parameter in my code editor. Just import. You can see it will be added the new visualization parameter. So these things I want to add as a layer. Just copy the same line of code and apply. I simply change it's a free, and I put it's a. I put the layer name. You can put any layer name. I put it's a. Suppose agriculture. You can put any name, any name. So now it creates another layer. You can see the agriculture, false color and true color. We can easily add the different band combination. So you can see, find out this is the band combination. Okay, so this is the way we are just applying for the single date. So it's called that your single date imagery. So now how I can create the composite? Okay, suppose I want to use all of images, total 4 images. I just use all of images and create a composite. So it's very easy for creating the image composite. So image composite, we can use different types of composite. Suppose median composite, or we also use here the mean composite or mosaic composite. So you can see the function. Suppose median. Okay, median composite, it's very popular. So it reduces an image collection by calculating the median of all values at the each pixel across the stack of all missing bands, and bands are matched by the name. Okay, so when I apply the median function, then these 4 images create a single median composite image by taking the median of all values at each pixel and a stack of all missing bands. Bands are matched by their name. So just we try to apply the median function, then it creates the median composite image using all of 4 images. So let's go try to create this median composite. Take a variable. Suppose I put it's a median image. So just I call the filter date because it is stored total 4 images, and I want to create the median composite by using the 4 images. Just apply the median and then clip with my shapefile boundary, which is ROI. Okay, so then display this map dot add layer and apply the median image, and now run the code. So now it creates the another image composite, but it's called the median image composite because we are just use all of images. We are just use all of 4 images by taking their median pixel value and create this type of median composite. Basically this layer, these images. So you can also add the color. Just click on here at the band combination. Suppose SRB, and you can see it show the large value look like that. So same process after median, just apply the scale value and offset value. So just multiply these things and also add the offset value, then it will be okay. Just apply. So now run the code. Yeah, this one. Just click on here. Suppose I put here red, green, and blue. Just apply. So now we find out this type of median composite image look like that. So this is the median composite imagery. It generate from total 4 images middle pixel value, okay, and create the median composite. And why median composite is very important? Because when you work with large area, okay, suppose I want to create the imagery for the whole country boundary of Bangladesh. So whole country boundary of Bangladesh, single tiles or single image is not enough. It cannot fully fill up my whole study area. Then we need to apply the median composite. Suppose I will show you the example. I simply import the Bangladesh boundary shape file. So here I already imported. Suppose these things I simply import. It stored the Bangladesh boundary shape file. I put the name, suppose BD. Okay, so I need the result for BD. I need the result for the whole country boundary of Bangladesh for Landsat 9 satellite imagery. So for that, what can I do? I just simply change it. Suppose I filter bounds with BD. Just put here BD. Okay, and then same. And now run the code. It show the layer error description length exists the maximum. Okay. Okay, just let me remove the shape file. I just take a geometry, suppose just take a rectangle which is covered the, just I draw the rectangle. So this is my study area. I need the satellite image for this study area. Okay, and I put this geometry name as a BD. So now run the code again. Oh, sorry. Clip with BD. Sorry, because of which change. Okay, just put here the BD. Clip with your shapefile variable name. Okay, we put the name as the BD. So now it's worked. So we find out. Okay, let me import the Bangladesh boundary shapefile again. Okay, and then remove the previous one. I put it's a BD, and now run the code again. Same problem, it show the result layer error description length exists the maximum. So for this problem we just take the rectangle, or it's a district boundary shape file. Okay, so let me try only for the boundary. only for the boundary, not district boundary. Okay, let me just remove it. Okay, I take the boundary from this USDOS website dataset. Just import the table. And previous class I discussed about that, how we can easily get the boundary shape file from this dataset. I put the name, suppose BD. This table I want to filter earth engine dot filter dot equal, set the equal country NA, and put the country name, suppose Bangladesh. So now this BD it is straight to the Bangladesh country boundary shape file. Yes, so now it's work, but we face a problem. You can see, so it's not this part, there is no image, also this part there is no image. Why? Because this type of place there is no image less than 1% cloud cover. Okay, so it's very important when you work with some place it show there is no image. So this place there is no image less than 1%, and also that this place there is no image less than 1% because a coastal land. So for this, what can I do? For this, just simply increase the cloud cover level. Okay, just increase the cloud cover level. I put the suppose less than 10% all of cloud pixel images. Just run the code. Now check what happened. So now this part is complete, but this part is still not completed. So we also increase the more cloud level. Just we simply increase, suppose 20. Now let's check. So now it's fully fill up. You can see fully fill up our boundary. So it's very important. So basically when you work with coastal area or river bank or any place where always cloud formation, so then less than 1% image is not available. Sometime it show the 0 or null value because this place is not less than 1% image is not available. So then you need to increase the cloud cover level. Okay, and now if you just check it, check this layer, click on here, and we can add the suppose red band, green band, and blue band, and stress in 98%, and apply. So now you find out this type of imagery for the whole country boundary of Bangladesh, and it's a median composite. Okay, it's a median composite image. Okay, how many images in here? Total 94 images. Okay, this total 94 images middle pixel value create this composite. And it's very important when you work with big study area, so then single tiles or single image is not fully fill up your study area. Then we just apply the median composite, then it fully fill up our study area. So now we can easily use these satellite images to create the different types of remote sensing work, land use, land cover, or NDVI, or anything we can do. Okay, suppose I put here the another band combination near infrared, red and blue. Apply. Okay, so now I find out this type of median composite for the whole country boundary of Bangladesh. So I can also apply any band combination. Suppose I put here short wave infrared one and near infrared and below stressing 98%, and apply. So now just simply import, it will be imported, and copy the visualization parameter, just copy and set with the layer, just set here. I put the layer name, suppose median composite. You can put any name. So now run the code. Okay, so this is the process. First process is that I discuss about the single date imagery. Okay, so when you work with single date images for your small study area, but when you work with big study area, then single date image is not fully fill up, fully cover, is not fully cover for your study area. Then we need to apply the median composite. Sometimes we also use the mosaic composite. So for that I will show you discuss about that how we can easily apply the mosaic. But median is very powerful because when you apply the median, it takes the middle pixel value, middle pixel value, and automatically remove unnecessary cloud pixel. So that's why you also find out the more neat and clean satellite imagery when you apply the median composite. So this is the way to work with that. Okay, anyone any question about the full code, you can ask me. Any question or any confusion, you can ask me, please. Any question? Yeah, please.
Yes. Yes, sir. I have some doubt. I wanted some explanations. When you are doing the composite,
Yeah.
you multiplied something and then you added offset.
Yes, yes.
I didn't understand why you did that.
Okay, so these
Could you
things,
please explain?
okay, so these things basically, if you check the result in our data set, it show the mean and max value look like that. Basically it's the globally these things we simply convert, okay, in the reflectance value. Okay, so this is the digital number. So this digital number we convert into reflectance value. So that's the region we just use the scale value and offset value. Okay, so this digital number of the band we just convert into reflectance value, satellite image reflectance value. So for reflectance value, getting the reflectance value or reflectance pixel value, we are just simply multiply the scale value and add with offset value. Not only for this data set, you also check the other data set for the modis. We also find out some scale value, we find out some offset value, as well as for the sentinel. So basically this thing is that convert the digital number into reflectance value, satellite image reflectance pixel value, just conversion. When you just use this scale value and offset value, it just applying the scaling value and reproject the scale value. So that's the region where I use the scale value and offset value. This scale value always multiply and then offset value always add with our images. You can see for after creating the median composite, we simply multiply and also add to conversion. Okay, also you can see I also do in here for the conversion, okay, to get the reflectance value.
Okay, thank you. Just to confirm, are those values the same for all the bands?
Yes, same. You can see all the bands are the same scale value and offset value, same. Okay, and the same value. All of bands. So that's why simply multiply with that and also add the offset because the same for all of bands. Yes.
Then another question.
Please.
When you're selecting the band combination, are there some criteria you have to follow? Like you have to select the band.
Yes. So for that, okay, like I will show the one reference. Suppose Landsat 8 band combination. So you also try to follow this. I also send this type of link also. You also try to follow. So then you can easily get the idea for the band combination. If you check it, it's called the 432. Okay, basically red, green, and blue. Red, green, and blue. When I select, then I find out this type of color. So it replicate close to what our human eyes can see. While healthy vegetation is green, and the flora is the brown, urban feature appears white, gray, and water is dark blue or black. Also you can see it's called the color infrared 543. Okay, so basically near infrared band, red band, and green band. So for that we find out the vegetation show as a red color. Okay, and better red color show the healthy vegetation. Okay, dark areas are water and urban. Then 764. Okay, short wave infrared 2, short wave infrared 1, and red. So then we find out this type of, so this is the 652. Then we find out this type of feature. So we are use the different types of band combination to identify different types of feature easily from the satellite images. This is the geological feature we also find out. Okay, also the bathymetric feature we also find out using this type of band combination. So you also try to read it, then you also get the more better idea about the band combination. Not only for that, we also use the different types of band combination to detect the different types of feature from satellite imagery, and it very useful when you work with land use land cover classification mapping. So in the land use land cover classification mapping, we are just use different types of band combination and identify different types of land use land cover classes. So I'll also discuss about the more details about that, how we can easily work with land use land cover and also use the band combination. Then you can easily get the idea, more better idea. Yeah, any question, please?
So thank you. My question is,
Please.
what happens if I not use multiply and scale and offset? What happens to image?
Okay, so this multiply and offset, if you skip this part, then you don't get the proper reflectance value. Okay, it just show the digital number. Okay, it show the number, but when you multiply this scale value and offset value, then we find out that accurate reflectance value for each bands. Okay, suppose if you check, click on here, and then click on here. So now we find out, you can see this type of information, this type of median composite. You can see we find out this type of value. So this is the value for SRB1 0.045. It's a reflectance value. If I don't multiply and add, then it show the very large value. Okay, it show the value high digital number, but now it show the accurate value. Okay, this type of bands pixel value, reflectance value we find out in here. Okay, if you don't multiply or add the offset value, then it show the digital number. Okay, you can see all of them, you can find out SRB1 value, SRB2 value. So all of bands value you can easily find out in here for this coordinate. So band reflectance value we can find out. So that's the reason to use the scale value and offset value to get the accurate reflectance value. And not only for this data, if you check data information catalog page, if you find any dataset have a scale and offset, you try to use it. Okay, so a scale value always multiply to get the better pixel reflectance value always. Suppose I show the one example. Suppose Modis. In the Modis data, suppose let me open. Suppose this data. Just I open. So in the data you can see it also provide the scale value. So you must use the scale value to get that better pixel of NDVI. Okay, otherwise it show the very large number, large digital number. So this large digital number we convert into the reflectance. Okay, reflectance value. So just simply multiply, then it will be reflectance and find out the result. So I'll show you this process also, how we can easily also work with that. So basically in the Landsat and Modis and also some Sentinel-2 data set, we also need to use this type of scale value and offset value. If you check it for the Sentinel-2 also, surface reflectance, we find out this type of scale value. You can see 0.001. So this scale value you must use to get the accurate reflectance value. Otherwise it shows the very large value. We cannot get the proper result. So you always try to use this type of scale value and offset value. Offset value is the currently added for the Landsat. Okay, because it's day by day it's developing this type of data set or also updating this type of data set. So this type of value when you use, then we find out the more accurate reflectance value. Okay, so this is the way to work with this type of scale value and offset value. Okay. Okay, and this is the way for filtering and displaying the satellite images. Okay, but here you can see I use lot of line for adding this type of code. Okay, so when I just use the filter bounds function, I take a new variable. When I just use the filter metadata function, I also take a new variable. So every time I just take a new variable. But if you want, you can just take the only one variable, and under this variable you can put all of function. Okay, so first time for your understanding I will just all of things at a same individually, but if you want you can also write the code look this way. Suppose just apply here filter bounce, same variable I just use filter bounce with bd, then put here filter metadata, cloud cover less than, suppose less than 20, then filter date, put the date, suppose 2025, from this time to 2025 0514. Okay, so now you can see I just spaces doesn't matter, you can put the anything anywhere, there is no problem. So spaces doesn't matter for the JavaScript, space is nothing. So now if I just check how many images is available, just okay, just let me just comment all of those others, just a comment, so then it not work, just a comment, just simply select and press Ctrl and forward slash, then it work as a comment, it not executed, just run the code. So we find out how many images, 94 images. Okay, so after applying the filter bounce function, filter metadata function and filter date function, how many images we find out? We find out the 94 images. Okay, so these 94 images I want to create the median composite. So for that just use here the dot median. Okay, and then in this time you can see if I just run the code, it show a problem. Okay, it show the problem, size is not a function, size is not a function, because when I apply the median function, then this variable L9 is stored a single median composite image, so that's why size is not work. Okay, size function is only work for collection, size, this function work for collection. Okay, but when I add the median, this variable stored the median composite, single median composite image, so that's why it show the result is not a function. If I just remove the median, you can see, and run the code, it also work, there is no problem, because now this variable stored the image collection, but when I apply the median, it's work as a single median composite, that's the reason size is not work. If you check the function, suppose just check the docs tab and check the function for image collection, you can see image collection. In the image collection we can easily find out a function for size. Okay, size is available for the image collection, but when I apply the median, then this variable stored the image, single median composite image, so that's why size is not work now, and it show the message size is not a function, because L9 is a single median composite image. Okay, and then I just apply dot clip function, clip. If you check the image is available for the clip function, if you check it, it's available for the where is the clip? You can see the clip function, clip is available for the image. Okay, so when I apply the median, this variable stored the image, and image I can apply the clip function. Okay, so clip, this function works for image. Okay, this function, this clip function works for image data type, and size function works for the collection. Okay, so now I just click with my study area, which is BD, and now we display the imagery. Okay, just display the imagery. Okay, just add the coordinates. So just add the map dot add layer, and I have to display the imagery for L9. Just copy, and also copy the previous visualization parameter and run the code. Okay, it's so size is not work. Just I remove it because size is work for the collection, but now L9 is a image composite. Okay, this image composite including total 19 bands, all of bands, and it also visualize our this type of imagery. And you can see here, in this case, I am not applying the scale value and offset value. So after median, just apply the multiply the scale value and also add the offset value to get that reflectance. Just copy the scale value and also add with offset value. Just run the code. So now you find out this type of map for the whole country boundary of Bangladesh. Okay, so this is the way when you create with the median composite. So in this code, basically I try to explain about that two things. First thing is that how we can easily create the median composite, and second part, how we can easily display the single date imagery. Single date imagery basically for the specific single date, not composite, just single date. Okay, so these two things I hope you can easily learn, and you also try to apply. Okay, so don't need to memorize, just understanding and then try to apply. Okay, then I hope you can easily learn. And have any confusion for any function or any line of code, you can ask me again and again. I try to give you the solution or answer. Okay, so this is the way for filtering. So now how we can easily export this type of satellite imagery. Export the satellite imagery. Okay, so let's go try to discuss about that how we can easily export this type of satellite imagery. Suppose this imagery I want to export, and further I want to open in the QGIS software or ArcMap software. Okay, so for exporting, when you export the satellite imagery, we need to apply the function. Just I simply write here export. You can see export image. So export image to asset. So basically we can export total 4 way. Okay, so export dot image, export image to asset, export image to cloud storage, export image to drive. So this is very popular because when you apply this function, this image is stored in your Google Drive. Okay, it is stored in your Google Drive, and from the Google Drive we can easily download and then work with that. And this is the cloud storage. So Google Earth Engine is also help you to get the data in the cloud. So you can also buy the cloud storage in the Google Earth Engine. So then you can also store it in the cloud storage, but it's a paid. Okay, it's not the freely available. For the cloud storage is the paid version. It's not available. So export image to asset. So it export your image and store it in the asset tab. Okay, in the asset tab. Suppose this image I want to export and store it in the asset tab. So it also possible. So then we need to use the export to asset. Export image to asset, and when you download it in your it's stored in your drive, and from the drive we can download it as a GOT file format. So let's go. I try to show you that this function how we can work with that for exporting. Just I click on here, it will be imported in our code editor. So now here you can see this is the export image to drive. So create a bash task to export an image as a raster to drive. Okay, so in this time we need to put the image, then description. Okay, image, basically the image to export. So which image you want to export, just write this variable name. Then description, it can be anything, human readable name of the task without a space. You don't use any space, no space. Okay, just use the underscore. Or folder, you can put any folder name. So folder automatically create in your Google Drive. Then you can see the file name prefix, it's not need for that. Dimension, it's not need. Region, basically it's a shapefile variable name. Okay, your shapefile variable name, just put the variable name. Scale is the resolution in the meters per pixel. Okay, resolution in meter per pixel. Per pixel size, just put here the pixel size. CRS, okay, it's a CRS to use to the exported the image. Okay, mainly coordinate reference system, it's also optional, not need to use, it's optional. Okay, just try to use it. So let's go try to apply. Also you can see it's very important, max pixel. Basically when you work with big study area, then we need to work with max pixel. Okay, max pixel restrict the number of pixel in the export. By default you will see an error in the export exist 1e8 pixel. So then we try to increase the max pixel value, it show the 1e8, so we try to apply 1e13, then it will be okay. So max pixel is need when you work with the big study area. Okay, and you face a error, then you try to increase the max pixel value, it also works, there is no problem. So let's go try to export it and then get